All right. So today we have my old friends Ajay Kulkarni and Mike Freedman, founders of Timescale. So welcome back to the Data Exchange podcast.
Thank you for having us, Ben.
It's good to be here.
And today we're here to discuss two viral articles that they just wrote. So one is on a new vector search capability for Postgres, and then the other one is the Postgres ecosystem. Um, so we'll get to those in a second. So for those of you who are not familiar, website is timescale.com, and the tagline is Timescale is Postgres made powerful, speed, scale, and savings. All right. So with that, let's go into vector search.
Yeah. Well,
Uh,
first of all, I think the credit for these two articles, which have gone super viral. Our first tweet has over 500,000 views. I think the second has close to 100,000 views. Super viral. The credit for that goes to the kind of the Timescale AI team, really led by Avtar, who was the PM, and Matt, who was the technical lead. And so Mike and I help, but they are doing like the real work. So I want to make sure credit goes to where it's due.
All right. So the first article talks about pgvectorscale, which is, I guess, a new Postgres extension that provides advanced indexing for vector data and improved search performance, specifically for approximate nearest neighbor type of query. So first of all, for people who are not following Postgres closely, uh, they might say, aren't there already libraries for vector search in Postgres? So what's the deal with PG vector scale?
Maybe I could start with this. So many people think of Postgres as, this, we like to say boring but awesome database. It's a workhorse that started 30 years ago. It runs, tens of millions of sites worldwide. Generally, people think of it started with more traditional, transactional workloads, e-commerce websites and whatever. But about 15, 20 years ago, the groundwork was laid for an extension model, which was basically hooks throughout the core code base that allows developers and companies like Timescale to basically push Postgres in new directions. And so from that perspective, it's become not just a database, but also really a database platform for handling a bunch of different workloads. So Timescale got its start by working on time series and events and operational analytics, things that have high volume. You want to do analytics, roll-ups, aggregations. But that was all through the extension model. So this is all about how do we take this core database that's trusted and loved by developers worldwide and now bring new capabilities, supercharge it for new types of workloads. And so that's why we talk about PG vector scale, an extension to Postgres. It's that core functionality now extended for vector search.
But weren't there already vector search capabilities, Ajay, before PG vector scale? So put PG vector scale in the context.
Yeah, so let
Vector.
me put this concept of Postgres. First is that we've been in Postgres ecosystem for 7 years, and what we have found is this general trend. I mean, Ben, you probably remember the days when you maybe had four databases to choose from: MySQL, Postgres, SQL Server, maybe Oracle. I don't know, right? Uh, and then, I mean, now we have like 500 databases to choose from, and there's had this explosion. And one thing we have seen in response to this explosion has been actually a reconsolidation to Postgres and using Postgres for everything. Why? Because like developers want simplicity, they don't want complexity, especially their database layer, right? Because you want your database to just work. Like the database, we often think about like your Wi-Fi. If you have to think about it, I mean, something is wrong. Like you just want it to work. And so first we've seen this big push towards Postgres. And we strongly believe that you should be using Postgres for everything and AI being part of that. And PG Vector is the first extension developed by a gentleman named Andrew Kane, who's a good guy. And it's really good. It actually kind of elevated Postgres to like the vector database level. But many people, including us, run benchmarks that show that like there are some scale and performance limitations. That like, hey, if you were to do this kind of seriously, you might actually want to leave Postgres and go to something like another more specialized vector database. Um, Based on that kind of thesis, we should be using Postgres for everything. And the current solution for Postgres, PG Vector, doesn't quite get you there for vector, but it's a good foundation. The team started working on a couple innovations last year. We launched it last year under a kind of closed source model called the timescale vector. And then earlier this year decided, you know what, we'd actually just want to give this to the Postgres ecosystem. And why don't we open source it? And the first thing we actually did is actually approach Andrew and say, hey, we want to upstream this to pgvector, just make it better. What do you think? And Andrew, has his own priorities and opinions, which I totally respect. And he said, you know what, this actually might be better as a separate extension. And so that is when we build a separate extension. But as you might notice, it's not called something totally random. It's called pgvectorscale, because the idea is that this thing works on top of pgvector, complementary to pgvector. You actually need pgvector to use pgvectorscale, but it scales it. But it's also MIT licensed, very permissible. All this put together, this actually pgvectorscale actually makes Postgres best in class for almost all vector workloads, maybe up until maybe the billions or something, like a pretty high end level.
Yeah.
Yeah.
Yeah. So Mike, what's the where do you start using pgvectorscale when you're already using pgvector? So what
Yeah.
yeah.
So one way to think about these extensions is that they're much like a database. You have data and indexes. You do the same with this vector class. So what pgvector defined was a data type, a vector data type that you use as part of your schema. So when you create a database schema table, you might declare one thing to be a vector type. And then on top of that, pgvector also added some additional indexing algorithms. There was, two of them. The more advanced one being HNSW. And that's like a hierarchical graph-based model. One way to think about it is that's probably works well up to maybe 10 million vector embeddings. If you have a small scale, hundreds of thousands, that maybe doesn't matter. Maybe a couple million, this is good. Where we've seen what we did, which was again to find a new index type. So much like a database, you could have different types of indexes. This is what pgvectorscale is doing. It's bringing some of the most advanced type of indexing directly into Postgres. And the interesting thing about that is when your data is in Postgres, is in pgvector, you don't need to move it. So it sits in your normal tables. In fact, it uses the same data representation as pgvector, where it is basically building a new index on top of this, and then all the magic happening there. So people could start from day one with pgvectorscale and this particular type of indexing we do. We could get into it a little bit more. There's no downside of it, or you could start something simple and at a later point decide, hey, I'm just going to create a new index, and you're off and running.
So before we get into the indexing, so in this space, Ajay, so people use the word hybrid to mean a few things, right? So the first thing is basically hybrid search, meaning I can do vector search, kind of these nearest neighbor algorithms with BM25 keywords, right? So I'm assuming this is possible within Postgres, right?
There are extensions that make that possible in Postgres, correct? Yeah.
And then the other thing that seems more natural in Postgres is the notion of hybrid, meaning here's vector search, and then maybe I will do something beyond metadata filtering and use structured data to help my vector search results. So that seems a lot more natural inside Postgres, frankly, than some of these.
That's right. And I would say a third thing, which is related to the second one, which is if you're building a new AI application from scratch, you don't want to have to fuddle with multiple databases. You just want to build it all in the database, Postgres, and build it all together. And then maybe at scale, maybe you can separate, optimize, whatever. But in the beginning, you just want to build, and I think having it all together in Postgres, having the OLTP with the time series and now with the vector, it just makes that really easy.
Let me be the judge of that because I'm gonna go through features and see if you guys have it, right? But um, so for example, right? So scale. People talk a lot about scale in this vector search world. What is the scale of pgvectorscale? As far as you can tell, what's the largest known usage of pgvectorscale?
The largest known usage is in the hundreds of millions of vectors.
But not billions, not billions.
I mean, we haven't benchmarked it that far. There's no reason. I mean,
That's in production. That's in production serving
yeah,
customer-facing
yeah.
applications.
We have paying customers in the hundreds of millions. This is like a real life use case, you know, and this is like how they make money. Um,
But this is
uh,
this is time scale, not
no, no, this is PG vector scale.
okay. No, no,
Yeah.
but the this particular use case is in the Timescale managed service cloud Postgres environment.
So yes, so two things. PG Vector Scale started off as a cloud-only offering that we've had for 9 months. PG Vector Scale has been open source for 4 days. And so in those 4 days, I don't know how much people have tested it, but I can tell you that like we have paying customers using the same exact thing on our managed service in production for months, in the hundreds of millions of vectors,
Oh.
which I feel like is a better, like proof point than whatever benchmark you run on your laptop. I don't know.
So Mike, in this space, of course, there's the buzzwords that I have to throw at you and put you on the defensive, right? So first one is horizontal scalability. Second one is separation of storage and compute. So now you're in the defensive. I'll let you.
No, I'm not. I'm not in the defensive. So, Timescale, the company in our cloud,
Yeah.
Timescale Cloud has really evolved over the last couple of years to be a cloud native platform. So, what do I mean by that? So today, from day one, actually, Timescale had separation of compute and storage, like you say. You could independently scale them. You could scale compute up and down. You could scale it to support horizontal expansion of
But
people.
this is time scale, not Postgres.
There's kind of a one way to think about this is that Timescale has done two things. Timescale has built Timescale DB, which up to today, Timescale DB, which basically brought these time series superpowers and event superpowers and analytical superpowers to Postgres. That has improved scalability and performance. The other thing that we've done in our managed cloud is basically built a modern managed Postgres environment for scale. One of the reasons we need scale is because we commonly see workloads in time series and events that are very large. For example, one of the production use cases we see on Timescale Cloud is over a petabyte in size. You don't typically see most Postgres deployments of a petabyte. And we commonly see customers with hundreds of terabytes of data using our cloud very comfortably, right? That has been innovation both with the things that one thing that Timescale does is we do innovate within the database with extensions, and we innovate around the database with our managed cloud.
And to be clear, Ajay, so for people using what Mike just described, it feels like Postgres. So in other words, it is.
I mean, it is Postgres.
So all the things that they're familiar with in the Postgres world map.
Yeah, I mean, is RDS Postgres? Does that feel like Postgres, or is that Postgres? RDS Postgres is Postgres. And Timescale is the same way.
Interesting. So, what about real-time index updates for vector search? Does that work in your?
Yeah, so you could. There's two different types of ways to think about indexing. One is batch updates, and one is incremental updates.
Come on, you're the real-time people, right? So it should be real.
Yeah, so incremental updates absolutely work. Look, over the next couple of years, are we going to continue to chip away performance faster and faster? Sure. I mean, that's the natural evolution of software. But completely, one of the reasons, like Ajay said, this is not the alpha release of an unused open source software. This is a thing that has already been in production with customers serving, production workloads, for 6 to 9 months now. And we have people who are constantly streaming in data about devices, markets, events, and that they want to constantly, of course, update their data. Their vector.
All of everything you described in terms of real-time and incremental updates maps over to your vector search.
Yeah. Incremental updates. PG vector scale supports incremental updates. Yes.
Yeah. Interesting.
And in fact, we could talk a little bit more, but one of our innovations around even indexing was the incrementalism of the way it does streaming. And actually, I can get into the details, but one of the ways that streaming interface is good is it actually more naturally support updates and deletes. And specifically the way that Postgres and many databases handles deletes is that they actually just mark them as deleted. It's called like Tombstone, rather than actually modify the data. So when they're marked as deletes, that means that when we incrementally read them in, we filter them, the engine filters them before they ever go to the application. So it very naturally actually supports incremental deletes. Also, because of the changes that we made to our algorithms to support this kind of asynchronous streaming interface.
So in this space, people also talk about, what kinds of vector indices they support. So you mentioned a few, Mike, earlier. So I guess without naming names of other systems, uh, in terms of just the support for vector index types, are you kind of basically almost, I mean,
Well, we're essentially best in. I mean, there's IVF flat,
you-
there's HNSW, and then we just introduced a streaming disk ANN. So disk ANN was this paper from out of Microsoft project called Vimana, and then our team built some innovations on top to make it streaming. Uh, and with this addition of a streaming disk ANN, Postgres through pgvector and pgvectorscale is now best in class, essentially equivalent to any other vector database in terms of index the indexes.
So there's also, Mike, you folks also mentioned this statistical binary quantization. Can you talk our listeners through what that is and why it's important?
Sure. So, and generally, as you talk about scale, which is in the name, the question is how large is each representation of the vector embedding? And so, where this comes about is quantization has been a technique across a bunch of AI applications and these models to actually just effectively compress down or reduce some of the precision that you have with these in the vector themselves. So they could be more compressible. So you could fit them in less memory, or if given a fixed amount of memory, basically store larger embeddings, right? And so this is just, what we've done is improve their kind of best in class is this form of binary quantization. And we found just some improvements that actually, gone through a fairly investigative experimental way of like looking of things that led to basically higher compression rates. So you could actually store more vectors in a smaller amount. And that's what this is. That was this main improvements. And of course, the game here, the reason why this is good is you want to actually keep more of this in memory. And as we get into the hundreds of millions and billions of rows, we're going to constantly basically build algorithms that map between what can be kept in memory and how do we effectively make it take advantage of disk. And so the kind of improvement here is that with some of these improvements, we could fit more in memory, so we have to go to disk fewer, and we basically allow us to more efficiently use disks through these, the disk ANN algorithm from Microsoft, and then the improvements that we made when integrating it into Postgres via streaming algorithm.
So I guess you guys fit into this observation that I and many have made, right? So that these existing database management systems can add vector search much more easily than the vector search people can add DBMS like capabilities. So do you feel like at this point, based on the use cases that you've seen for vector scale and its uh, prior incarnation as a closed source plugin, that people are actually leveraging the fact that you have these DBMS-like features. So not only are they actually loving that you can do vector search, but hey, these guys have governance, they have access control, all sorts of things. So Ajay, so what's your sense of
Well, we think about this a lot. So I think in general, in business, if you want to build a big business, you either have to go super broad and horizontal or super narrow and deep. I think that in general, there's the two options. And I think in vector, I think you're going to end up with those two different comes to two different things. I think the specialized databases of the world, there is no way they can, the specialized vector databases of the world, there is no way they can recreate what's in Postgres. No way. I mean, it's not only just the years, but like you're competing against the world and just building everything into a time series, geospatial, this, that, blah, blah, blah. Let alone the reliability, versatility, all these different things, ecosystem, all these things, right? So there's no way for them to catch up there. But what they can do is build a super great and deep experience if you're building AI applications. And I think that's the way direction they're going to go. And then the other direction, which is, kind of the direction we're going, is the super broad. It's like, hey, if you're building a AI application, you don't want, let's say you're building something from scratch, right? Because you want to maybe innovate, you want to experiment in your larger company, you're building a startup or whatever. From scratch, do you want to have to spin up a Postgres and a specialized time series database and a specialized analytics database and a specialized vector database just to write your first line of code? Like, of course not. That's terrible, right? And what you want to do is just build it all in one place, Postgres, and as you scale, optimize as necessary. And I think that is what we are enabling with pgvectorscale is to keep doing that on Postgres. But whatever that high watermark is, at which point you say, hey, I need to move on to something specialized, we're pushing that even higher. So that like this simplicity you can have for a long time, maybe forever, because most people aren't going to have vectors in the billions, but and so I think that is our approach is to go really broad. But I'm not bearish on the vector database market. I just think, I mean, some of them won't survive, but I just think the way they're going to go is going to be super narrow and deep, and that's going to be like just a different business model than what
Or
we're
they
doing.
evolve away from they might become RAG as a service kind of
Exactly. I think
offering.
I
Going up the
think
stack.
I think everyone, including the vector database companies, I think everyone agrees that vector databases are getting commoditized. And so the question is, then how do you differentiate? One way is to go broad, and one way is to go narrow, like a rag stack. Totally.
So the one thing I would push back on is the ease and the simplicity, right? So I have Postgres on my laptop. I use it every day. I love Postgres,
Hmm.
but uh, the reality is it's still a database that you still have to manage and do things, whereas some of these vector search offerings are just because they're not databases, they work nicely with whatever generative AI framework you're using. They're not only work nicely, they're in the documentation as examples. So for many developers, the reality is they will start with one of these systems because they're more
Have you
native, they're more native to that ecosystem.
have,
Until
I'm sorry, go ahead. Yeah, sorry.
no no until you folks in the Postgres community embed yourself into these generative AI frameworks all the way down to the documentation level, right? So
So, well, I was going to ask a leading question, which is, have you tried to run like some of these specialized databases like Pinecone on your laptop?
not all of them, no. Yeah.
No, because you can't,
Yeah, yeah, yeah.
because you
Yeah,
can't,
yeah, yeah, you
because
can.
it's not
Yeah.
open source. It's a
No,
service,
no, no, no.
and you're like, oh, it's hard. You have to run it yourself. You can't even run Pinecone yourself. And so my point is like, first, if you want something that is just easy that someone else manages for you, there are many Postgres hosted offerings, including us, who can do that for you. So I think apples to apples is not this on your laptop and this as a
No, no,
service.
but my point, Ajay, is
The integration. So the second point,
embedded in that ecosystem,
a
right?
second point is everything in that ecosystem, whether it's OpenAI, LangChain, Llama Index, Olama, they all also natively integrate with Postgres. All of them do. And in fact, what we are doing is the second extension we lost last week, which is PGAI, actually brings native integration inside the Postgres database. So now you can start calling the OpenAI API for both embedding and generation right from your Postgres database. And the Olama folks reached out, and we're gonna build that soon. And then LangChain folks reached out. We'll build some type of integration there soon. So I think Postgres is already there one way, and we're building native AI integrations the other way with the help of all these providers.
So, Mike,
Yeah, when we look.
there is one feature I want to ask you about, which is the streaming post filtering.
Sure. Sure.
Uh,
Let me talk about that in a minute. Let me just add, Jay mentioned this. So Llama Index, LangChain, actually we announced, we had partnerships with them, and we actually have libraries. If you go to LangChain, you'll actually see documentation about like an embedded in the LangChain library, and it's a Python library like every other ML engineer is doing now, where you're just writing your Python, and behind the scenes it's in LangChain, and behind the scenes it's working with pgvectorscale and Postgres. So I think what we're going to see is that that ease of use, that developer experience is really gonna collapse and be very smooth.
Make sure you work with Haystack too.
Yes.
Yeah. So streaming
the
post
streaming.
filtering, what is it and why is it important?
Yeah, so this is a little bit of a I'll go technical for a minute, but try to keep it high level. In fact, this was, and I think it's also an example of how open source and extensibility win in the long term, right? Because when Pinecone initially started, Pinecone pointed out something with an implementation, I think, of pgvectors HNSW, and said, well, one of the problems is you had to call it on a fixed set. And so what do I mean by that? What that means is when you try to do a vector search, you ask the vector search of like, tell me 100 records that are the closest. It runs that against the index, and it comes back with 100 records. That sounds fine. But then the question is, what happens if you actually expand the model and say, give me the 100 records and where where the state equals Texas. Actually, one of we have some people who are doing state by they want to chat with their data on a state by state basis to look at how rules and regulations differ by state. And so because that's a precise thing, the LLM is not great at reasoning about what's in Texas versus what's in Oklahoma. So generally they do that as post filtering, right? Now the problem with post filtering is if it's scarce data, you get back this list of 100 things from your database, you filter it, and you have nothing left, or you have one record left. When really you want, 20 records about Texas. And so how do you do that? And so Postgres itself already had a model from it. The way its internal query optimizer work and executor work is it processes things on a tuple by tuple basis. So when you say give me 50, that is limit 50, it keeps processing it incrementally, tuple by tuple, until it hits 50 that satisfy all the requirements, all the predicates, and then it returns it. And so that's actually one of the ways that we change the algorithm, is that rather than the vector index return a bulk of 50 and then you're done, think of it as like the vector gives you a cursor or a pointer, and you keep traversing it throughout the vector graph, throughout the index graph, until basically the query engine says, I have enough for what I need. And so then it means pre-filtering, post-filtering, all that works basically completely transparent to the user. That's actually embedded all in the query engine that's part of the database.
So before we go to Postgres is great for everything, I have one question, Mike, to you that has actually nothing to do with PG vector scale, but have you been following these file formats, Lance and Nimble?
I thought you were going to ask this in a different direction, which was the what's going on with Iceberg and all that stuff. I know some of the work, but where I think we're seeing the common, I mean, broadly speaking, we're seeing that.
So basically, for our listeners, there are file formats that address some of the limitations of Parquet for this world of unstructured data. I'm not detecting massive uptake or usage yet. But it seems like when you read the thing, this makes sense, right? So what's your sense of long term? Will these catch on or not?
I think two things. One is I think we've certainly seen that, particularly in the data warehouse, data lake house world, the industry has decided we're going to have a separation of compute and data, and we're going to standardize our storage with some, cheap scalable object store like S3, and we are normalizing around a few types of data formats called Parquet, Iceberg, whatever. By the way, we think the same is happening operationally with databases as well. In fact, Timescale Cloud actually natively supports S3 tiering to Parquet, which is why we could store, petabyte scale databases all served through Postgres horizontally scalable, cost effectively, whatever. Whether or not, Parquet has a general format, you could actually specialize a little bit. We've actually done that ourselves with how we store Parquet for our tiered storage. We've done some special segmentation to improve the query speed. I'm sure there's going to be innovations. Whether or not some of those innovations end up being proprietary, whether or not they get standard enough to be wide the industry, we'll see. But I think that general trend we're seeing is cool data or warm data on S3 is a winner. I think that for very operational workloads, customer facing, user latency matters. We will absolutely still see, the use of traditional SSDs and whatever as they need to serve, those type of query patterns. And so this is just like, from 50 years ago, we've always had a hierarchy of storage, memory to disk. And I think that's the same is true in the cloud. Now we have local memory, local disk, remote object storage, and it's just another layer of that storage hierarchy.
Yeah, to me, it seems like they're not ready to replace Parquet for all use cases, especially for traditional analytics. And then the benchmarks that are emerging are mostly focused on ML and AI scenarios. And so, maybe
Yeah, I mean, broadly speaking, I think one of the other things that it's different is we think of related to like why it's useful to have this all accessible in Postgres is, the vector storage specialized databases, including in things like LANs, are all about storing your vector embeddings. Most of the time, you need more than the vector embeddings. You need the data, you need references, you need citations. So when things seem to hallucinate, you could figure out what makes sense. And that often, now some of the vector databases, well, you could store metadata in your vector database, but it's limited, and then you're creating another copy of it, and is it the right stuff? And so I think a similar thing with when we think about this, what means Postgres for everything is that you already have your data in Postgres. The vector embedding might be a different table or index. You can cross-reference it. You could join it at query time. I think the same thing true is for file formats. Yes, maybe there are some file formats that are good for vector embeddings, but you're probably going to pretty quickly connect it back to the underlying data to reference and cite. And so I don't know if it makes sense to have a completely separate file format.
Which is what Lance and Nimble do, right? So, okay, so let's go to Postgres is great for everything except for a few things that I will point out later. So I guess we've already hinted at it by discussing how Postgres has basically become viable for people interested in vector search. But what are other pieces of evidence beyond vector search that you folks would want to cite? So, for example, what are some of your favorite examples for how Postgres is starting to kind of pop up everywhere?
I think my favorite one is this use case called time series that this company, Timescale, has been working on. No, I mean, what is actually really funny is that the one thing we realized about Timescale is that it's a very good time series database. Is it faster than something very bespoke like KDB that's used in real-time trading applications? No, KDB is faster. But in order to use KDB, you have to know KDB, you have to know Q, which is a programming language that's like APL-like. And with Timescale, it's like close enough. And it's everything you know, and you can store everything in there. So that's actually what we found with the reason Timescale exists is because people wanted to use Postgres for everything. They wanted to use it for their relational workload, their time series workload, the analytical workload, and geospatial workload, all of which we support now. I think that is the evidence we're seeing, and I think the success of pgvector has been
and now vector search. Right?
Yeah, and pgvector, by the way, I mean there are people out there. There are people I know who are investors in some of the leading specialized vector databases. And I've had coffee with them and I've been like, hey, like I think Postgres is going to win. And they've said to me, oh, I think Postgres is already winning. Like if you look at total adoption, it might be higher in Postgres for vector data than any of these specialized one individually. So I think these are the
Because
two data points. Yeah.
I guess at the end of the day, right? So, even if you take what I said earlier as true, which is basically it's much easier to get started in this vector search systems, right? So at some point, when you get serious, you're doing a lot of work, you're going to approach your infrastructure team, and your infrastructure team is going to say, well, that's a separate system. Can't we just use something that we already have? Let me investigate. And then the infrastructure team might end up recommending Postgres, right? So it's just natural, right? So
Something we already have,
why introduce something else, right?
something you already have, something we already trust.
Yeah.
And also, hey, if we already are a vendor providing this for us, then it's also minimizes the business risk of introducing a new vendor.
Right, right. So, Mike,
And you mentioned when,
what are
I was
your
going to say,
favorite Postgres is taking over the world examples beyond time series and vector search?
uh, I think we went through, we had an article, a blog post a couple months ago where we basically looked at every specialized database and we realized that there was effectively an equivalent Postgres extension, which gave you, let's call it, 90% of what it did. For you could actually build queuing systems in Postgres. Maybe they're not as scalable as Kafka, but a lot of use cases don't need that. You could build. I think a big example is MongoDB. Like Postgres's JSON-B is really powerful, right? And so I think a big thing that people liked in Mongo is like, hey, we can have unstructured data. Well, you can have that unstructured data very naturally in Postgres. We're actually seeing other extensions do this for things like search. And so I think we just see it again and again. Now, it's kind of like those things of you could, if you always build a hyper specialized widget, you could probably, for that very narrow use case, make it better in certain ways, but it always comes at some cost. And so I think to the extent the market is like, I don't think that this is an either or, I think it's an and, but I think the and of how much Postgres could serve that market or how much Postgres already is serving that market is pretty dominant. I mentioned JSON, for example. As you know, we deal with time series and metrics and events. Almost today, like when we look at IoT data or we look at event data, a high percentage of that actually has JSON data because often some of the data that is really well structured and some of the data is typically unstructured or you don't want to predefine all of that structure. And so developers have naturally gone to this hybrid form. And the point is, it's not a choice. It's like I could do all these things together. And I think that has just been really led to a lot of developer experience and time to market as opposed to like building this on multiple different systems.
So the one data format, maybe graphs, might be a bit awkward in Postgres. It's probably doable.
I mean,
but
vector
then,
search is a graph problem.
yeah, no, but graph, as in graph analytics, when you're really doing multi-hop kind of, then it becomes a little awkward. It's doable, I'm sure, but it becomes a little awkward, right? So the other,
I'm looking. There's actually an
There's
Apache
an
project.
Apache. It's called AGE or AGE. It's
Yeah.
actually part of the Apache Foundation.
Yeah.
It's actually a graph database for Postgres.
And
Yeah, yeah.
I'm looking at benchmarks Apache AGE versus Neo4j and to see what people say about these.
No,
And again,
you should compare it to Kuzu, right? So Kuzu is the
oh, it's Kuzu? Okay, cool.
KUZ. So one trend that I would like to ask you guys about is
Yeah.
embedded databases, right? So there's
Hmm.
DuckDB, Kuzu to some extent in the
Mhm.
graph case. So how does the rise of embedded databases, the SQLites, the DuckDBs, how does that relate
Yeah.
to Postgres? Complementary?
I had Mike, do you mind if I take the first? Uh, very complimentary. I actually had coffee just this morning with someone who is embedding DuckDB inside Postgres, you know. And so I think I think it, obviously there's some use cases where SQLite or DuckDB is enough. You don't need something with the versatility of Postgres. Uh, But there's also scenarios in which Postgres becomes better by embedding DuckDB inside of it.
How does that work? Like embedding DuckDB inside Postgres?
It's giving an interface to a broader,
Bigger.
S3
Yeah.
lakehouse behind it. Yeah, yeah.
There are a few ways.
So
It's still evolving and but it's yeah it's like kind of cutting edge state of the art type stuff. But there are ways. Yeah.
but so basically when you run a query, what's executing? DuckDB or Postgres?
From what I understand, so this is again something that is not has not been launched yet. This is what someone is working on that I talked to this morning, just this morning. Um, I think uh, I think Postgres executes it, but then actually passes it along. Actually, in the planning process, I think passes it along to
So
DuckDB.
is it like a push down?
Called a foreign data wrapper. Postgres has this environment to have other executable engines where it could actually make remote calls. So even within Postgres, you could actually call out to like Oracle and Mongo and other things if you want, often to join data.
But is this something you folks are seeing? People using DuckDB and Postgres or
But
SQLite and Postgres together?
I think more broadly, I mean, this is a particular use case to try to kind of have pushed down to some lake houses. But I think more broadly, and you mentioned before lake houses, I remember. I think these are often serving different
That's a
parts of the market.
great word, lake house.
It was a great branding. Databricks did a great job there. I think they serve different parts of the market. Like, what is the traditional data lake, data warehouse, whatever? It's that you have like data coming from all your organization. You don't know where it is. You want to centralize it. You throw it there and you figure out what to do with it later.
Hmm.
And I think mostly, not only, but databases more traditionally served operational use cases. So you are actually building known products, whether internal or external. They could be internal data products, they could be external customer-facing mission critical. And that means they have higher availability needs, they generally have a lot lower latency needs. They often have higher throughput needs because it's not just like your data team doing a BI query to your thing in an ad hoc fashion. It's that you have hundreds, thousands, millions of customers who are hitting your database concurrently. And so from that perspective, where embedded database, SQLite, DuckDB traditionally sat is actually a way for data teams to do local analytics, local storage on like a laptop or something. They were never meant to be multi-user databases where you have to build data products. So
Right.
I think it makes a lot of sense. You want to download your data scientists, you want to download a bunch of files. Local SSDs are big. Download hundreds of gigs of files onto your desktop and do some querying on that. Works like a charm, right? But you're not going to build necessarily. It's not really designed to build these like high availability customer facing applications, serving 24/7. So I think they're just the great thing about software is you purpose build it for different use cases.
I know the theme of this section is Postgres is great for everything, but I'll put Ajay on the spot here. So when talking to your customers and users, right, so that are using Timescale, so what workload are they using a separate system for? That what's the most popular workload that somehow they're not using Postgres, they're using something separate?
I mean, I think that's the question, not maybe as the point in time today, but maybe the trends that we're seeing,
Yeah.
because I think that's maybe more interesting. The trend we're seeing is that, look, we all grew up within this era of OLTP versus OLAP, database versus data warehouse, totally different things, oil and water. What do you want Oracle or do you want Vertica? Like totally different things, right? And one thing we have seen the past 7 years with Timescale is that those lines have completely blurred, like Timescale, we have people who use Timescale as a data warehouse, you look at the use case of ClickHouse. ClickHouse is sometimes is like a big query replacement. Sometimes it's like a database, OLAP database replacement. It's kind of like this. So I think those lines are blurring. The thing that we see that is maybe still somewhat distinct is who is the person using the system? Is it the developer? Is the data analyst? Is the data scientist? And that is how we see things crystallizing. Like the reason developers especially in the last year, actually, we've seen quite a few migrations from Snowflake to Timescale. And the reason people do it isn't because like along some data warehouse dimension, Timescale is better, is that it's just as good, but that they want to use the Postgres because they're developers, you know? And on the flip side, if you're a data analyst who loves Snowflake and doesn't use Postgres at all, there's no reason to be using Postgres for that, you know? So I think that's the way the lines are, you know, of course they're blurring now that like Databricks and Snowflake are overlapping and like all these things are happening. But like I think at the end of the day, we see the segmentation along personas at the very least between the technical user and the non-technical user. And so, um, you know, what we often see is people will run, developers will run like their own data warehouse in Timescale, but then we'll have a copy that goes into Snowflake for the business folks, you know, and I think that makes sense to me because I think like if you extrapolate kind of technical trends, all these systems can be built to do what the others do. You know, it's just architectural trends. You know, but I think what's different is that when you build for a certain persona, then you're actually making you have an opinion that's then really hard. You know, do you invest in a like a CLI to access your data, or do you access in a WYSIWYG editor? I mean, it depends on the persona. Developers will never use the mouse; they want to stay on keyboard, right? And if you're a non-developer, like I don't want like a really boring terminal. You want like something WYSIWYG. And so I think that is how we see it, but maybe not for the reasons it might seem. It's not for technical reasons, but I think it's because of the customers are ultimately have different needs.
So, Mike, do you see any workloads that people are still using something else besides Postgres?
Yeah, I mean, I think it was related to what I talked about before. You know, when are we? Is it meant to be for a developer, or is it meant to be for these data teams? You know, is the thing that I care about is that I'm centralizing my data between Snowflake and HubSpot and enriching with that and doing a DBT job over there, and you know, all these people running on each other's toes, and you're worried about uh, governance between them. That makes sense to bring these type of data lakes and data lake houses and warehouse that are working out. I think what we have seen is that databases like Postgres and Timescale are ultimately used to build products, and there is developers who have ownership over them, as opposed to one database to serve an entire team. What we also sometimes see, Jay mentioned about a data warehouse built on Postgres. Postgres is actually most companies' first data warehouse, right? Especially when they're small, and it works great like that. I think what eventually happens is they reach a scale where sometimes it's the data volume, but most of the time it's the integrations and ownership is this higher level kind of user experience is why that they start moving to somebody like a Snowflakes or a Databricks.
Yeah,
But by the
interesting.
by the way, Redshift is built on Postgres. So one of the leading data warehouses is built on Postgres. And actually what's really funny is that if you asked me this question a year ago, I would have said something different. Probably would have said, hey, if you need a data warehouse, pick something else. You need a database, pick Postgres. And then what we started seeing the last year, I actually remember reaching out to Mike to be like, hey, for some reason we're seeing a lot of migrations from Snowflake. And and like I saw one, I saw two, I saw three, and I was like, I think it's a trend. I'm not really sure why. It's really interesting because it is making me question my own assumptions. And that is when we kind of developed this like evolved, opinion, which is these lines really are blurring at the technical level, but they're still separate at the persona customer level.
And one of the reasons we saw this was because as this data got together in something like Snowflake, people started saying, hey, let's develop products, data products on top of that. And it turned out that often it didn't really satisfy what developer needs, both in terms of the developer experience, the programming, the latency, the performance, and frankly, the cost. It was, not architected to this, so it ends up being a lot more expensive. And so those are some reasons why those workloads, which might have, hey, it's easy to start here because our data is already there, realize they're not well suited for that. And so they've moved back to to Postgres and Timescale. And let me caveat before, so I don't frustrate somebody. So your audience doesn't question this. I would say that what I'm talking about is 99 or 99.9% of companies. If you're Google, Facebook, Apple, Uber, Netflix, they have their own needs, and most of them custom build all their infrastructure for those needs. I'm saying if you're starting a company, if you're probably at a big company, if you've been running Oracle for 30 years and are trying to figure out how do I move to the cloud, Postgres is where you want to be.
I mean, this is the whole like, is COBOL dead argument? You know, I mean, COBOL's dead. Actually, I know a bank in Colorado that their mainframe is still built on COBOL, and my friend is a developer there working. Yeah, man, people still use fax machines. People still use things like that are essentially antiquated. But like that doesn't mean it's not dead. You know, you essentially look at the net new, you know, and like the kind of the kind of the center of the fairway and not the exotic exception. Yeah.
All right. So the only thing I'll say is let's not sleep on the lake house. All right.
Yeah, yeah,
So
yeah, yeah. I think
yeah,
actually what's more interesting is how the lines have blurred between data lake and data warehouse. You know, I think the lake house is a
yeah,
great example of that.
yeah.
And no, I totally agree. And this is, I mean, to be fair, the only reason we haven't talked about it is because we actually see less of that world than
Yeah.
just the pure data warehousing
Yeah,
world
'cause,
and the database world. Yeah,
they're
we do.
happy. Their needs are
Hey,
met.
there you go.
They're happy, right? So, great vision, open source DNA, and continues.
I hear Databricks has some really great technical advisors who are advising
Oh,
them.
yeah,
Yeah.
yeah, world class. So let's close with by returning back to vector search.
Yeah.
So obviously the PG vector scale, I guess you folks had that as a proprietary solution for a while. So rolling it out to open source, you could kind of see that it would probably work, right? So what's the next innovation that you have planned as far as generative AI kinds of workloads? Maybe it might not even relate to vector search, but even if it's vector search, so what's next in the pipeline for the Postgres community or Timescale specifically in this area?
Do you want to, Mike? You want to take this or want me to take it?
Sure. I mean, today we mostly talk about vector scale, which was the vector indexes and databases, and there's obviously a technical roadmap there. The other part that thing we announced this week was PGAI, and Ajay already alluded to this, which was run OpenAI embeddings and soon other forms of embeddings directly in your database. And I think that's where there's a lot of where kind of we're very excited what's happening. I think we've seen all these really interesting use cases of RAG to build to build chatbots and
So
train.
just to clarify, so your embedding pipelines are going to be right there in
You're
your
embedding calls directly in your database, and
yeah.
Postgres is already a great. I mean, the vector search is actually the vector indexes you need to perform retrieval as part of a
And
pipeline.
PGAI because of I guess the letters PG, I'm assuming it's open source.
Yes, it is a similar to pgvectorscale. It's licensed under the Postgres license, very permissive, much like the MIT or BSD license. Yeah. And so
And
this is something that we've built, but anybody can contribute, kind of welcome. It's on GitHub. And this is a way to like really help you build AI applications directly in your database. Imagine that you actually already have your data being in it. You want to perform your entire embedding and then search pipeline. So normally when we think of RAG, it's that you've already trained your data. Now, what you actually can do here is you actually are writing data to your database, and at the same time, you're actually incrementally computing these embeddings on what's being written. And then you could also have LM queries that come in and chat with it. So you, again, don't need to build very complex pipeline of data over here, move it, compute chunking, insert it. It basically all gets run directly in your Postgres database.
so in the case of PG vector scales, you guys had a year or so to run it in production. So what's the status of PGAI in terms of maturity and polish?
So PGI is earlier. I'd say the thing that we had done at the same time of our proprietary is we actually had written other tools we'd called Vectorizer, which did this pipeline. We had those libraries which could work with LangChain and LlamaIndex, and some of that learnings has been translated to PGAI. But it is relatively new. But one of the other interesting things is actually it's written in Python. So when you actually want to extend PGAI, pgvectorscale is written in Rust. Timescale is written in C. Those are all different levels. We chose Rust again. I think a lot of excitement around it as development. Frankly, it's faster to do a lot of really careful text operations and binary operations because it's a safe language. But PGA is written in Python, and so you could actually extend it, adopt pipelines, do more embedding, and write in Python, and then it gets dropped into your database. So it's much faster to develop, and we expect it to move much quicker as well.
So let me close, Ajay. So one of the things that people are talking a lot about this year is multimodal data. So what does Postgres have to offer in the world of multimodal?
I think when we say Postgres for everything, we're essentially saying Postgres is the ultimate multimodal database. It's the every modal database, as if you want to play on words. And so, yeah, no, I think like multimodal, it means you can support some use cases. I think Postgres, you can support all use cases. And so that's what I would say. I think what's tricky is that, um, again, with multimodal, like let's say you support, I don't know, you support.
No, multimodal in this context means computer vision, text,
Oh,
Yeah.
I'm so sorry. Yeah, yeah,
speech.
yeah.
Yeah.
I will say we talked about last year with we've been proprietary. One of the companies using us in production was doing it for machine vision applications where they're doing vector searching on images, and so there you can store images on in Postgres. You might not want to for again you probably just dump it in S3, but you certainly store the embeddings on it. So there's different. I think that Jay's point was right in that it's an everything modal database that it has any type of type. It has blobs, it has integers, it has strings. So it is multimodal in that sense. In the case of a model, it's probably a powerhouse for certain things, and there's probably other, architectures you do elsewhere. So I think it's one part of, it's a core part, but it could be one part of obviously much richer AI apps.
By the way, final question. So for people who are getting excited about Postgres, what are some key Postgres events that people should go to just kind of get a sense for how vibrant this community is?
That's actually a trick question because there are some very vibrant Postgres events, but they tend to be primarily for people who are building Postgres, like
Okay.
the actual core developers
Yeah.
and not the users. I think if you're a user, I think there are some online forums and blogs, our blog being one of them, the Timescale blog being one of them, where you can go for resources. There's no one big Postgres user conference, but often at like a PyCon or other conferences, there'll be like a Postgres track. Um, but what I would say is, just start consuming the content and you'll find the connections.
And speaking of content, in closing, I would say this Timescale people, I don't know what they do, but seems like every blog post about, especially time series and vector search, appears on Hacker News. So they must have some kind of in with the Hacker News managers over there. But I
Well, we're
swear,
not a YC company, but I think it's, you write good content and developers are interested in it.
yeah. And with that, thank you.
Ben, thank you so much.
Thank you again.